Alright, welcome to day 2 of Polynomial Functions, chapter 7.1. And today we're going to be looking to evaluate these polynomials with other variables. Okay, this will be something that you're going to use later on in the chapter as well as in math classes to come, so make sure that you really understand this concept. So if you recall what we did yesterday, if we were given a function like f of x equals 3x plus 2, and we wanted to find f of negative 2, wherever the x was, we put a negative 2. So here we had 3x plus 2, so we put in the negative 2 for x. And then we just simplified the right side of the equation. So 3 times negative 2 is negative 6, plus 2 equals negative 4. Okay? We're going to be doing the same thing today, except instead of numbers, we are going to be doing it with letters and possibly numbers as well. Okay, so if we want to find p of a squared, if p of x equals x cubed plus 4x squared minus 5x. Okay, so here instead of plugging in a number, wherever we see an x, we're going to put an a squared. So p of a squared is going to equal, there's an x here, so we have a squared cubed plus 4a squared squared minus 5a squared. Okay, so wherever we saw an x, we put that a squared. Okay, using order of operations, we want to do exponents first. Okay, our power of a power property states that when we take something to the power, so a to the second to the third, we can multiply those exponents. So that's what we're going to do. So we're going to have a to the 2 times 3 plus 4 times a, we multiply those two, 2 times 2, minus a is 5a squared. And we end up with a to the 6th plus 4a to the 4th minus 5a squared. Okay? If it says to find 3qx, that means that we're taking the whole function of qx and multiplying it by 3. So if q of x equals 2x squared minus 6, then 3q of x is going to be 3 times that whole thing, times the whole q of x. So when we do that, all we have to do is distribute. So 3 times 2x squared is going to be 6x squared, and 3 times negative 6 is negative 18. So 3q of x equals 6x squared minus 18. Alright, let's do some examples. So here it says, find t of b cubed if t of x equals 3x minus x squared. So wherever we see this x, we're going to put that b cubed in its spot. So we're going to have t of b cubed is going to equal 3 times, there's an x here, so I'm going to put my b cubed in there, minus, there's another x, so I have b cubed squared. Okay? 3 times b cubed is 3b cubed, minus. When I have something to the power, I can multiply those exponents. So b to the 3 times 2 is going to give me b to the 6th. And that is your answer. T of b cubed is 3b cubed minus b to the 6th. Alright. This says find g of a minus 1 if g of x equals x squared plus 3. Okay, so now wherever I see an x, I have to put a minus 1 in for x. So my g of a minus 1 is going to equal, I have an x, so I'm going to have a minus 1 squared plus 3. Guess what we have to do? FOIL! Yay! We all love foiling, alright? So if we love our 2 by 2 charts, we're going to have a negative 1, a negative 1, and we're going to distribute both parts to both parts. So a times a is a squared, a times negative 1 is negative a times negative 1 is negative a, negative 1 times negative 1 is positive 1. Combine like terms. So a minus 1 squared is a squared minus 2a plus 1. And then we have this plus 3 left over. Okay, so this guy right here equaled this guy. The a squared minus 2a plus 1. These ones do not cancel. Negative a plus a negative a is negative 2a. And then we just finished by combining like terms, so we will have a squared minus 2a plus 4. And that is our answer. Okay? Here, we have quite an involved problem. It says find q of a plus 1 minus 2q of a if q of x equals x squared plus 3x plus 4. Okay, this problem is going to be like a three-step problem. We're going to first want to find q of a plus 1. We'll do this in different colors. Okay, then second step is that we're going to want to find 2 of qa. And then third step is we're going to want to subtract them. You ready for this marathon problem? Alright, here we go. So this is my q of x. Wherever I see an x, I'm going to put an a plus 1. So q of a plus 1 equals x squared. So I'm going to have a plus 1 squared. That means I get to FOIL. Plus 3x, so plus 3 times my a plus 1 plus 4. Okay. So here if I FOIL or distribute, however you want to see it, I'm going to do it over here. It's this exact same problem except with pluses. I don't want to confuse you, so I'll do it again. We have a positive 1, a positive 1. So we're going to get a squared, and 1, which that gives us 2a. So we're going to get a squared plus 2a plus 1. This right here, all we have to do is distribute. So 3 times a is 3a. 3 times 1 is 3, and then we have this plus 4. Okay. If we're combining like terms, I have this 2a and this 3a. So I'll have a squared. I keep the term itself, which is the a. 2 plus 3 is 5. And then I have 1 plus 3 plus 4, which is going to give me 8. Okay, so this is our blue answer. Hey. Okay, that's q of a plus 1. All simplified. We can't simplify it anymore. Okay? Next, we need to find 2q of a. So, if this is our q of x, that means that we're putting in an a for x, and then we're multiplying it by 2. So we're going to have 2q of a is going to be equal to 2 times. Everywhere we see an x, we put an a. So I'm going to have a squared plus 3a plus 4. And then here I'm just going to distribute my 2 to all parts. So 2 times a squared is 2a squared. 2 times 3a is a positive 6a. And 2 times 4 is 8. Okay? And this is my green answer. So now, last but not least, I subtract. So I'm going to have my qa plus 1, which is a squared plus 5a plus 8 minus, we have to subtract the whole polynomial, so we want to put that in parentheses, 2a squared plus 6a plus 8. Okay, so we want to look at like terms. So here we have our a squareds. So my a squared stays and I subtract the coefficients. I have 1 minus 2, which is going to be negative 1, a squared. And then I have my a's, which I'm going to have 5 minus 6, which again is negative 1. This is negative. And then I have my numbers. 8 minus 8, which is 0. I don't have to write my zeros, so I'm left with negative 1a squared minus 1a, or if you want to just write it negative a squared minus a. Either way is acceptable. Okay? So that is polynomial functions evaluating with variables.